Now in this video of C language, we are going to cover another technique of passing values in a method when you are invoking it through parameters is call by address. As in the previous video, we have already seen what is call by value, which is the default way and where we used to make a copy of the values. Means one copy is the actual parameters, another copy is the formal parameters. Both are the separate variables, and if you'll make changes in one, it will not be reflected in the another one. But here in call by address, basically we are going to pass the address in a pointer. Rather than passing a value, we will just send the address of a particular variable to the formal parameters, which are nothing but the pointers. And if you are making changes through the pointer, it will actually make the changes in the original variables which we have passed as the formal parameter. So basically we can also say that here in call by address we only have a single value of values, means single copy of the values. Single copy of the value means whether you will change on the actual parameters or formal parameters, it will reflect changes in the same memory location itself. So this is what we do in the call by address. Let's have a look in the implementation as well. Like here you can see in again this swap method, you can find like there is a pointer type of parameters, that is pointer x and pointer y, and when we will call this swap method, we will just pass the address of the a and b, means our variables. So if you will directly make the changes in a and b, or you will make changes through the pointer, ultimately the value of this memory location will be changed. So the benefit which we can find with call by address is, if you are working with the user defined data types that may exceed 8 bytes, as by default pointer will occupy 8 bytes, but if you will create any structure or union and you want to pass that as a parameter in a method, then what happen if you will do the call by value? Suppose your structure that we will cover in a coming videos, that's a user defined data type. Suppose your user defined data type allocates 20 bytes in memory. So when you will pass that in call by value, so the multiple occurrences or multiple copies of that 20 byte value will be there in the primary memory during the execution. That may degrade the performance, but the size of pointer, as we know, will remain same, whether it's an integer pointer or any customized data type pointer. It will only occupy 8 bytes in the memory. So in the cases of large data types, this call by address can be beneficial for the performance. So let's see a practical implementation of call by address, and there we will create the method swap and will pass the address. So let's have a practical implementation of it. Now in call by address, again we are using the same example which we have covered in the previous video as well as in the presentation in the same video. So here you can see in the signature of this method, I have not passed the variable, but it is a pointer which will contain the address of any particular variable only. And by the time I'm calling this swap method, I'm not passing the value of a and b, rather I'm passing the address of a and b using ampersand symbol. So here when I will say ampersand a, the address of a will get copied to x and the address of b will get copied to y. And even here when I'm doing the swapping, it will point the same value 100 and 200, because ultimately x and y are pointing the address of a and b. So it doesn't matter whether you access a particular value through the pointer or the variable, the values will be the same. So here when the swapping is done, so actually the swapping is done on the same location of x of a and b. So the value which was there in the address of a will be assigned to the b, and the value which is there in the address of b will be assigned to a. So since we are storing the value at a same location, not like call by value where we had multiple copies of the same values and they were unaffected with each other. Here the value is stored at a same location itself.
So when I'll execute this, you can see initially A was having 100, B was having 200, and after this swapping, A is 200 and B is 100. So this is how you can work with the call by reference whenever you want to save some spaces. Like here, this integer will occupy lesser memory than the pointer, because here by default pointer will take 8 bits and 8 bytes, and here the integer will take 4 bytes. But in case you are working with any user defined data type which are probably consuming the larger memories, so when you will do the call by value at that particular time, in particular location, so the multiple occurrence of the same value will occur in the memory, and which will be having a same value. For example, if you have designed a new customized type of suppose 40 bytes, and if you will make multiple copies of the same thing, so it will just occupy the memory in the multiples of 40 byte. But if you will use the pointer at that particular point, it will definitely save the memory during the execution and may make your execution faster.